All right, welcome back. This is the after work video. So this will be the last video in this topic, unfortunately. Running out of time very quick, but I've got an hour to put into it now. So I will share my screen and get started right away. Okay, so last video I was working through this example in the lab. I'm optimistic that I'll be able to finish it by the end of this video. So, oops, it looks like I've got two instances of GNS running now. Okay, so here we go, but I'll close this because the cron job rebooted it. Yeah, and I got a little bit of a late start. Just needed an hour break after work today. Okay, so, but here's the lab. So we've got our confederations. We're going to have sub-autonomous systems. So for each sub-autonomous system, as was mentioned in the last video, you're going to need a full mesh. In our topology here, we've only got full meshes if we either have just one router by itself, because then you don't need any links at all, or two routers. Once we add a third router, we no longer have a full mesh because there's a link missing connecting back to this. So our only options are to either have a sub-autonomous system for each router, or to have two in one and then the rest. The option that, so we have all sorts of options. I'm sure you can do the math and that'd be interesting to do, but that would be getting sidetracked. So I will just explain what I went with. So I went with A and B in a sub-autonomous system, C and D in their own sub-autonomous system, and then E in its own sub-autonomous system. And the numbering I used was 65001, 2, and 3. So the end of last video, I finished the requirements. So first you must configure the network interfaces. Then this one I skipped because I think they kind of put this in the wrong order. And I did this one first, which is to configure the IGP. You're always going to need an IGP. I used ISIS. And then I'm also going to skip the routing policy to advertise BGP routes. So where I'm at now is I'm going back, now that I finished the IGP, to this step, and I'm going to configure the internal peers, and I'm going to do it by following along here because I'm going to need to use these special Confederation commands to complete the objectives. So we've got our two routes here in autonomous system 65001 that I will be adding the configuration statements to. And then the BGP statements as well. So I got to try to make sense of these and then implement it. Okay, so confederations. So we need a special autonomous system number for our confederation. So one thing you'll notice is that in all of our sub-autonomous system numbers, we've got different AS numbers. It looks like we've only got two, but they are going to be different. So here they've only got two sub-ASs, but within each sub-AS, so this is 64512, we've got a confederation number, 64513. And not only that, the confederation number matches. So what you're doing is, I'll pull up Paint to explain this better. So with route reflection, you have your routers and they're not in a full mesh. So yeah, and we'll see Okay, so these are our routers that are not in a full mesh here, but that's totally fine because you just take one of the routers and you make it a route reflector here, and then your neighborships. So do I got a dotted line, something like that? I'll use a lightning bolt. So this lightning bolt, oh man. Well, that's not really gonna work. Let's see here. I think what I might be able to do, maybe use a different thickness for a line. Let's see here. So here's the outline. So I can use like a crayon or something. Yeah, so this isn't, well, crayon's not quite different. Let's see here. Oil's probably quite a bit different. No, oil's not that much different either. Well, shoot. Marker? Maybe marker, different color. I can just use a different color. Pencil looks quite a bit different. Okay, so in my pencil, so here's all my physical links. You can see we don't got a full mesh, but in pencil, I'm going to show how all the BGP neighborships are established. So this is all you need. You just need BGP neighborships. Back to the route reflector, and since BGP is established over TCP, you can do it over as many hops as you would like. You can do it as long as you can reach the IP that you want to peer with. So of course, the normal limitations of networking apply. If you don't have a route here, it can't reach it. You'll have a BGP neighborship that is inactive and will remain inactive until you resolve all of those issues on the network so that it is reachable and can go into established. But this is all you need. Without any kind of route reflector, you would need a full mesh. So you need a link here, here, and then a link here as well. So the other option you have, this is route reflection, is route confederation. So with route confederation, oops, and I'm going to switch back to no outline. Oops, or not to no outline, to solid color. Perfect. Okay, so now with route confederation, we don't have any special kinds of routers. These are just regular old routers. We don't have route reflectors and we don't have non-route reflectors. What we have are just regular old routers. But in a regular BGP autonomous system, you would have 6.5. So you would have it like this. So here's my autonomous system, 65000. So here's all my routers within this autonomous system. Now remember, this full mesh requirement is for iBGP adjacencies. So even for this route reflector scenario I had before, where we've got a special route reflector, and then we've got in pencil, you can see these are the neighborships. So in this scenario, it's just like this scenario where this is to, oops, and let me change this to solid color. There we go. So this is for iBGP. So it's all in one autonomous system. It's to overcome the iBGP requirement where all routers within an autonomous system have to be cabled together full mesh. You can overcome that by having a dedicated device that has all of the neighborships, and then you just enable the cluster ID, and then it'll serve as a route reflector client. So that's a way you can do it. Another way you can do it is say, so for this same autonomous system 65000, we can say, well, you know what? Let's have this router here, instead of forming an iBgp connection to this one, or this one, or this one. So here we don't have a full mesh, just like before. So instead of forming an iBgp connection, because there's no restriction for eBgp when it comes to full mesh requirements, we can say, well, you know what? You're no longer in 65000 temporarily. You're going to be in 65001. And you're going to be in 65002. You know, 3, 4, what have you. This could be in 1. It's just you've got to have, for each sub-autonomous system, you've got to have that full mesh requirement satisfied. So this can be in 65001, but this one could not be in 65001 because it's not in a full mesh with the other 65001s. It also can't be in the 65002 because that's already in use over there. So now what you can do is you can form eBgp connections between all of these. No problem at all that you don't have that requirement with eBgp, but you can also say that they're part of a confederation. And you can say that confederation is 6500. So that's my explanation of this. You can, what's a better way to explain this? So I can't really think of one, but hopefully this is kind of clear that you get around that limitation of having iBgP neighborships requiring a physical full mesh cabling. You can get around that by forming eBgP neighborships and then using a special technology confederation to say that all of these eBgP connections are actually an iBgP connection for this autonomous system. So all the sub-autonomous systems, you're just saying collectively, these are all together and they represent this other autonomous system. So that's how you can get the same thing using confederations that you got using route reflection. Yes, you're going to have different ASs, but they're sub-ASs, so they're going to be all representing the same entity. So I feel like I'm coming up with a good analogy slowly but surely. I guess I want to go with like buildings, where like, of course you're going to build. So like let's say like a table. So if I'm building a table, I've got you know, the top. I've got some legs on the table. So like they're different things. It's the top of the table and it's the legs of the table, but that doesn't change the fact that it's still a table. And you can have, you know, a wooden table, you can have a metal table, you can have a picnic table, you can have all sorts of different kinds of tables, but it's still a table. The route confederation is kind of taking that approach, where you can have different kinds of eBgP connections, but you've got a special mechanism to say whether this is a metal table, whether it's a wooden table, whether it's a big table, whether it's a small table, it's still a table. So you're kind of doing the same thing with route configuration, whether you've got a cluster of devices that are full mesh that have the same sub-autonomous system, whether each device has its own sub-autonomous system, anything like that, they still represent the autonomous system 65000. So it's just a collection of sub-autonomous systems that are all either Ebgp connections or in a full mesh within themselves that represent a greater autonomous system. So it's not necessarily that it's all Ebgp, because you can have this sort of thing going on where I've got this topology that I want to support. So this is a full mesh topology here, but this is not, of course. So you can give these all the same sub-autonomous system and form IBGP connections between them, and then you only need to form the Ebgp connection here. But if you don't have this link here, now you can't form IBGP connections here because you haven't met the full mesh requirement. So your only option is to form Ebgp connections across the link for all of these. So they all need to have their own autonomous system. Sorry, sub-autonomous system, so that you can use a Confederation number to represent a full autonomous system. So route confederation in BGP is just aggregating a collection of sub-autonomous systems into a larger autonomous system that you represent to the outside world. That's all it is. So a lot more complicated conceptually than route reflection. I think route reflection is what most modern is what most ISPs go with. In the real world, I've seen route reflection far more often than route confederation. I have seen route confederation, but when you're at the point where it's like, you know, you're working with this stuff, you've got a 10, 15, 20-year career, you've got CCIEs coming out your ears. So, you know, obviously my job wasn't to design and even implement route configuration on the second largest service provider in the United States. But I did have access to one of a pretty influential co-worker of mine who went on to become a principal engineer, said that the most important thing you can do pretty much in any technical role, especially if you want to get ahead, is just stay curious. So get on any device you've got right access to, do a show run, do a show interface. You know, curiosity doesn't necessarily kill the cat. That's something you hear a lot, and that's just not true. Curiosity gets you ahead, it allows you to grow. And not only that, networking is uniquely suited to it. I mean, what's the harm in doing a show run? Like, yeah, there's things can go wrong on the device, but if it's just a result of you doing a show run, it's really a greater issue. It really is not a big deal. And not only that, you can look through the archives too. Sometimes there's archives of show runs. So networking is I think uniquely suited to foster curiosity, because it really allows you to dig in and look at things, because the commands are all right there. I mean, you can just do show question mark on just about any device, and you can see what you look at, and you can get explanations of anything. You know, it's all right there for you to dive into. It's an open book. It's just your job to go and read it. So went off on a tangent there. I think I was explaining kind of my experience with route configuration, and you know, obviously I did not design it, I did not apply it, but I have seen it in the real world. That's just what I wanted to say. Okay, so let's go with, okay, so yep, we can form IBGP connections between A and B and C and D, but then we'll need to form EBGP connections between B and C and D and E. So let's do that. Okay, so now we won't need to create a, right, we won't need to create a, shoot. Well, I'm just gonna wing it. Okay, so let's do set routing options, Confederation. And let's have our Confederation AS. So this is going to be the main AS that we're advertising. It's going to be 6500. Or let's do show configuration or show pipe display set. Yeah, so we went with 65001, 02, and 03 for our sub ASs. So let's have our main AS that we're going to advertise to other service providers be 6500. Okay, so now we need to add members of this confederation. So now there's going to be 3. Remember, there's going to be 65001, 2, and 3. So let's add those. There you go. So that's all that is needed for that. So the next thing we're going to need to do is form our BGP neighborship. Now we do have a full mesh between A and B, so we can form an IBGP connection. Oh, I'm already in configure private mode. I think I'm going to, yeah, I'm going to set up a loopback IPv4 address to form these IBGP connections. I just want to make it very clear what's going on. So set interface hello 0, unit 0, family inet, address 10.0.0.1/30. Okay, and now edit protocols, BGP group IBGP, IBGP, and then we'll say sub AS 65001. Yeah, so they use a similar syntax. Let's call it subAS, sub-AS. I just kind of like that subAS. I think it drives home the, I don't know, I just think it looks nice having 2 underscores and having these all together. So I'm gonna go with that. Okay, so then let's do set, oops. So this is interesting, they've got a type internal here. Because it's all devices within. So these are all IBGP connections. So these, I haven't looked at their diagram yet. I'm kind of curious to look at it. So I'll look at it. But I've been avoiding looking at it because I won't get it during the test. So there's kind of no point in looking at it. Oh, but yet you can see they do have a full mesh in both of their sub-autonomous systems. So they've only got 2. I've got 3. And then they've got this EBGP connection, but it's a confederation. So their autonomous system that they're going to be actually exchanging through the public internet is going to be 17, but their network consists of sub-autonomous systems, each having an actual full mesh. So my topology is a bit more complicated than that because I don't have full mesh connections except for between 2 devices at a time. So I'm going to have 3 sub-autonomous systems instead of just 2. Okay, and I think they're a little bit unclear here because they're saying the border device needs this configuration. Well, all devices in here includes the border device, so it will need this configuration as well. And you can see the groups are named differently. It just makes it a bit unclear that this requires both this BGP group and this BGP group. Okay, so yep, this is going to be type internal. Set local address. So I added an address. So it could be 10.0.0.1/30. Oops, don't need the subnet mask. Neighbor 10.0.0.2. There we go. And it's really not super complicated, not that difficult at all. This is the only configuration we'll need on A. So I will configure B, check that IBGP neighborship. That will be up. And of course, I'll need to do an Ebgp neighborship between C. Yeah, and I'll draw this out to make this more clear, I think. So oops. Okay, these are locked together somehow, so I don't know. Okay, that didn't work. Okay, there we go. So that's working. Oops. I wish I could just undo all this. Okay, there we go. So I'd like to just draw a circle. Okay, there we go. I just want to make this very clear what's happening. Okay, so hopefully this makes it more clear. We've got our autonomous system that we're sending out to the real world, 6500 here, this whole thing, but it's just an aggregate of our sub-autonomous systems, which is 65001, 2, and 3. Okay, so I think that's as clear as I possibly can make it. So let's continue on with the config of B. Ah, shoot, I'm already half an hour in. It's bad news, man, because I want to just do one topic a day, so I want to finish this by the end of today. I think I can, though, so let's just try to move a bit faster. Yeah, and I think we'll need to add this to every single one. So the configuration is a bit more complex. But yeah, I think this does allow for, well, actually this might be why route reflection is more commonly used, because this is definitely more complex configuration. Then what did I say? 65001? Is that what I said for this one? Yeah. Okay. What? Oh, I don't need the /30. Okay, and I need to set up the family INAT. Okay, so it's inactive, but it takes a while for it to come up sometime, especially when you haven't properly designated one side passive. Unless there's something oh. Oh, so let's see here. Well, let's go on A and let's see if there's if I can ping .2. Okay, yeah, that's what I thought. There's a routing issue. Oh, okay, so it's here. Okay, so I think I'm missing adding this to this side. I think this thing is going to be missing from this side here. Let's find out. Yep, I was right. Cool, I'm developing really good instincts here. Okay, so now we'll see that neighborship start to come up. I really hope I have that refresh command on during the test. I have a feeling I will not. All right, well, let's see if I can ping it now. Okay, so the pings are good. Okay, so maybe there's another issue, or it just does take this long. Ah, okay. So one thing you might be confused about, oh, where's multi-hop? You know, you might have thought, I certainly thought, oh, that's what the problem is. I don't have multi-hop enabled. So this is IBGP, so I believe that's only necessary in EBGP. Okay, but that's been established now, so we're good to go. So we're going to need some more configuration on B, and that's going to be to connect it to the other autonomous system. Go back to the topology here. So B's got to have an Ebgp connection to C, sub-autonomous system 65002. Okay. Again, I forget what the neighbor is. So we'll do a show route protocol direct. Oh, protocol local actually. Okay, so the right facing interface here. So yep, it's going to be .2.2. Okay, so I think that is everything. So yeah, we just need one neighbor. Ours is going to be a bit different. They have that they have a different topology where they have a full mesh between 3 routers. So they've got 2 neighbor statements here because they've got to connect to more routers in their topology than I do in mine. Oops, one thing I did, well, actually no, I'm good because I'm going to be connecting to the physical interfaces. If I wanted to connect to a loopback using Ebgp, I would need additional configuration, but I don't need that since I'm doing neighbor. Additional configuration would be this local address here, and then I probably would need multi-hop since it's Ebgp. I'm not sure, it's not worth looking into. I need to get this done. I've got 15 minutes. I can go a little bit longer, but I've got 15 minutes. Okay, so yep, this one is good. It's in the correct autonomous system. So let's start with the Ebgp connection. You're wondering why I pause? It's because I'm legitimately like barely coming up with what I need to do. Hopefully it goes better for me during the exam. Okay, so let's see if that Ebgp neighborship comes up. Aha, so it's trying at least open confirm. Yep, that means it's going to come up, so perfect. Okay, so now one thing that I believe I can do is since they're in different sub-autonomous systems, I think I can reuse the IP addressing, but we will see. This will be interesting to tell. Okay, so this is my IBGP connection, and I can reuse those addresses because they're contained within their own sub-autonomous system. Perfect. So we're good to go pretty much. We also need the loopback address. Okay, but I think that's all we're going to need. There we go. So we've got all our confederations, we've got our Ebgp connections, and we've got our IBGP connections. Well, there's just one connection, so but of course we could have more IBGP connections if we did have that full mesh requirement. So yep, good to go. Now it's time to move on to D. So I think I can save some time, which I desperately need to do right now, by just copying over this config because it's going to be pretty much the same. So this is all going to be exactly the same, so I can just copy that over. Okay, and then this is going to be, for the most part, the same, but it's going to be .2. Oops, that didn't work. Okay, so now there's going to be some pretty big differences here. Well, actually, that's not true. These are going to, yep, it is. So that's going to be, yep, that's going to be quite a bit different. But here, the differences are going to be pretty small. This is just going to be .2 now. And then this is going to be .1. Perfect. Okay. So now that we've got everything good to go, pretty much, we're going to need to work on the Ebgp, which is going to be a little bit more involved. So I'll put it in the notepad. Okay, and this is going to be between 2 and 3. Okay, and then it's going to be to the neighbor, so show route. Oops, so this is on D we're configuring. So run show route protocol direct. So we've got, oops, local, I mean. Okay, so we've got .1 here, so it's going to go to 4.2. Okay, and then the pure AS is going to be 3. All right, so we've got everything looking good. Yep, the Confederation's set up with their members in it. So one thing I'm a little bit curious about is, do we need this to be a part of our members? Because we don't see it anywhere. I guess maybe we do because it passes through it, but I wonder if there's no harm, no foul. This is, if you know in the comments, please let me know. When building a route confederation, which is a which is an aggregation of sub-autonomous systems, do you need to require every sub-autonomous system in your confederation on the configuration of every router in your confederation? Or do you just need within each sub-autonomous system to include members of the connecting the connecting sub ASs. So if I had an internal router, let me pull up Paint really quick. So let's say I had a route confederation. We had 5 routers here. They were all in a full mesh. Yeah. So they're all in a complete full mesh. And then I've got a Ebgp connection here, just to another one here. And I wanted to build a confederation with 2 sub-autonomous systems, this one here and then this one here. So on this router here, that's buried deep within this sub-autonomous system, do I even need to configure that to be a confederation, to have this confederation member statement? Or do I only need it on the border routers that have both the IBGP and the EBGP groups? If I do need it here, do I need to include all members in the confederation or just the confederation number you want, and then the autonomous systems this one will know about, presumably just the one it's in? I think this is the right answer. You do have to include every single sub AS in every single confederation configuration, but I am just curious about that. So if anyone knows for sure, please let me know in the comments. All right, so, but let's move on to E. We're making really good time. We've got an extra 7 minutes. I mean, I don't have to stop this one right away, but at the same time, I kind of do. Okay, so let's do private, and yep, we'll just take router A, because that's going to be. Oh, actually, nope. It's going to be quite a bit different because it's got. Oops, and I never committed, so this card nope, and then commit and quit. Okay, so the configuration is going to be quite a bit different on router E because it doesn't have, it's its own router in its own sub AS. So we're going to need this, I think. See, I'm not sure if you need this or if you just need this. So let me know in the comments, please. All right, and then we're just going to need this. And the neighbor is going to be 4.1. And the pure AS is going to be 2. All right, and then we've got all that taken care of already. So yep, it's going to be pretty stripped down because we don't need any IGP configuration. It's just going to be a nice and easy, clean config. See, the reason I'm questioning that you would need all of these too is because what if you have like 100 sub ASs? You need 100 lines of config like this, or can you just abbreviate it on some of them? But I mean, if you've ever been on a production device, those show runs are a mile long. Like when I pull it back using Paramico, like I had to write a special function to be able to capture it all because Paramico wasn't able to pull back enough information. Okay, so yeah, we're good to go. Let's check all of the neighborships. Oh, let's make sure this comes up first. I think it just takes a while. Okay, so let's go down here to the verification steps. Yep, there it goes. So they're just verifying all the neighbors, and they're verifying the groups. So they're really not doing anything fancy. So let's just do that. We'll just verify, do a show BGP summary on everything. So it'll be our first round of verifications. Perfect. 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 Oh, we've got one that's stuck in connect here. Okay. Okay, and I think that's because I've got this twice here, so it's yeah, this .2 is configured on two different, because I configured .1 and .2 here as well. So I think this formed it with the wrong. Let's hear show route. Yeah, because we've got two connections to that. So yep, you can't, even though it is contained within its own sub AS, you can't reuse IPs. It doesn't work that way in a confederation. It's really not its own contained thing. Its own contained thing is the actual confederation, but not the sub ASs within the confederation. All right, but that's not hard to change. Okay, so I'll change this to .3. Oops. Okay, and then this one to .3 as well. Perfect. Okay, so then to, oh my God. Nope, I won't be doing that because I've got a /30. So I think I'll just use yeah, I'll just keep the /30s, but I'll use valid host addresses. So I'll use multiple networks out of the out of that subnet. So the next /30 is going to start at .5, so I'll use that instead of .3. Okay, so .6 goes on router D. Okay, so now hopefully those show BGP summaries will look a lot better. Nothing's going to change on E when I do it, but we'll see some big differences on these routers. It might take a while for this to, oh, why did I not change my, I thought I changed it. Oh, you know what, it's gotta be to, so I never changed my neighbor statements. I wish you could do a pipe display delete instead of pipe display set, because you would get the, I could just double click on the command then. Okay, so now hopefully things are going to look a lot better. No changes on router E, of course, but hopefully some big changes on router D, or at least in the process of making those big changes, which can take a while. Go a lot faster if I designated one side as passive, but yeah, it is 8:03 already, but yep, there we go. Not too much extra time. There we go. Everything looks good on C as well. Yep, everything looks good on B. And then, of course, A is going to be good. Let's not save a file, though. Okay. Oops, we did accidentally save a file, but let's look at this. Okay, looks good. And I'm going to clean up that file just because I don't like that. Okay. There we go. So everything is good. I'm not sure how to test that there is a connection. Let's try looking at some routes. Or you know what? Let's try this. Let's take a let's take a Cisco or something that boots up really fast. So that would be, yeah, a Cisco, or maybe like an Arista or something. Something that just comes up really fast. So yeah, let's use one of these. And then we'll put another one over here. All right, and then we'll cable them up here. So this is going to be 0. This is going to be 1. And then this is going to be 1. And this is going to be 0. Perfect. Okay, and then we'll cable these up. Okay. Yep, and then what we'll do is we'll configure a point-to-point connection on both of these. We'll redistribute these routes here into BGP using a policy, and then we'll try to ping end-to-end, and we'll take a look at how the routes are learned and take a look at the path, and we should see that it only goes from just through 6500, even though it's got these ASs in it. All right, so let's set up the Cisco. If it will allow me to do that. Okay, and it will. Sweet. Okay, I might as well fire up the other one too. It's taking longer than I thought it would to come up. Okay, there we go. So now it's up. So yeah, let's do a configure terminal. and then interface GI, and then it would be 1. Oh, 1/0. Yeah, and then IP address, we'll do 172.16.0. Well, let's give it a, yeah, let's do 172.16.1.1/30. Oops, 255.255.255.2 because it's Cisco. No shut. Okay, and then we'll do back router BGP 1, and then we'll do. Actually, do we need BGP on it? I don't think we do. I'm confusing myself. Okay, so let's go to A. Yeah, I don't think we're gonna need BGP actually. Yeah, let's go to A, and then let's do configure private, and then edit. Okay, so now let's do a edit routing, or edit policy options, policy statements, add to BGP, set from route filter to 16.0/3 exact. Okay, so let's see what the routing table looks like in B. Oops, so we don't have that route there. We should have it. Oh, I need an event statement. I thought that's all I needed. I need more than stuff. Okay. Well, I thought that's all I needed. So I'm not advertising anything. Why am I not advertising anything? Why am I not advertising this route? So, I mean, I'm not advertising anything, so that's clearly what the problem is. It's not advertising this route. What the heck? I'm really confused right now. I thought I had a good handle on this. I thought this was all I needed. What the heck? Okay. Yeah, I thought this was all I needed. Okay. I'm unfortunately it is 8:16. I wanted to move on from this topic and do one topic a day, but I just don't think I'm gonna finish this today because I can't. I thought it was gonna go really easy, but there's something very wrong to where this isn't advertising anything. And you can see I do have a route. To direct route. So this does match. So I wanted to put it into BGP, then accept. So I need something to show up here. Yeah, I need this to show something. I wonder if I don't need this statement. Oh, okay. yeah, I don't want to change it to BGP. Like, okay. All right, cool. Good call by me. Oh my God, what a nightmare. I almost gave up. Okay, so yep, now we've got it here. So I think it probably should propagate all the way over to the other side. Let's check. Yep, it did. And you can see we've got an AS path here, but it's in some special syntax. It's in parentheses here. So this is technically, I think that's to show that they are sub-autonomous systems. Okay, so let's set up the connection on this side to the Cisco device. Okay, so we've got that configured there. We're also going to need the policy. And the last step is exporting it. Oh God, that scared me. Oh, that really scared me. Oh, they're picking up the garbage outside. Okay, so set protocols, BGP group, export, add to, okay. Okay, so now we should see that. Oh, we won't see it populate yet, so I'm gonna do it and it won't show up. That's because I didn't, oh, it did show up. Did I configure this already? I didn't, okay, but I'll configure it now. Okay, so we don't have any sort of routing set up. But yeah, so we can't ping to that one because we don't have a gateway of last resort. Let's set up a gateway of last resort. Okay, and then let's set one up on the other side. Okay, so now we should be able to ping to 16.2.1. Perfect. So now we can do a trace route. Okay, I was kind of expecting that to look a little different since it's just all in one AS. I was expecting there to be some more hidden hops. I guess what I'm looking for is to just see if I can get some information about that route. I guess what I would like to do is I'm going to tear down that static route. Okay, and then I'm going to set this up with BGP, and we're going to form a iBGP connection. And this is going to be a completely different AS. So this is 65000. We're going to have this be AS1 and this be AS2. And then we're going to see what the routes look like. Okay, so router 1, BGP router 1, and then we're going to do neighbor 16.1.2. Oops, what else do I need? Oh yeah, I need PRAS. Okay, so now this is interesting. So I'm going to try it with the Confederation number for my PRAS, even though it is in a sub AS. Okay, let's see if that works. Okay, so it's in idle, it's not even, oh, okay, so that's not working. Oh, of course, because I don't have the other side configured. Okay. Okay, so I need a whole new group. Group Bgp to Cisco. Okay, so hopefully the neighborship will look better now. Ah, it's up. Perfect. Okay. So now let's set it up on the other side, E here. Here we go. So already we can see something pretty interesting happen. I formed a up adjacency to these routers, even though if I go on each of those routers and I do show configuration routing options, I can see that their autonomous system is not the autonomous system I used to form my Ebgp neighborship with. I can do that because they're a part of this is just a sub-autonomous system, part of the real autonomous system that aggregates all the sub-autonomous systems. That number is 65,000, and that is the number I used in my statements on my Cisco's. So everything looks good. Oops, show IP route. So I should, yep, and now I've got the other side through BGP. So now I can ping to the other side. I can trace route to the other side. And this is more what I was expecting to see. Now we can see that I'm learning it through, oh, wait, never mind. This isn't, okay. Okay, yeah, no, it's always going to be like this because it's routing it. Like, yeah, those are all the Ebgp hops. I don't think it will show up like that for because well, let's just look. So it could be routed 1, 2, 3, 4, 5 times. Let's see how many times it was routed. 1, 2, 3, 4, 5. Yeah, well, 6 times. 1, 2, 3, 4, 5, 6. Okay, so it is going to be routed even if it's through a sub-autonomous system and it's not between autonomous systems. It will still add a hop to it. It doesn't have any special things with hop, but we can see with the hops that happen because it's a confederation. Nothing different happens with the hop count. Okay, but we can see that the AS is reported as 65,000. So our confederation is working. We've got full connectivity. Come on, I can't even use, I'm seriously like trash. Like this video is going on way too long and I'm losing it. And I worked like all day too, so. And I worked pretty hard today. Today was kind of rough. Let's see here. Show route. Oh, show IP route. Yep, so of course it's going to look good on this side too, otherwise the ping would get there but never come back. So let's ping 172.16.1.1. Oh, no, that's directly connected. .2.1 is the other side there. Let's do a trace route on this side as well. And it'll report back 65,000. We won't even see any of those sub-autonomous systems anywhere from what I understand. So the last thing I would like to do before I end this video, which I am thankfully, is do a show IP route 172.16.1.1. And now if there's any kind of detail or extra, this is what I wanted to look at because we can see that we knew it via BGP2. Oh, so yeah, this is BGP2, but it's tagged with 6500 and those autonomous system show IP. Here we go. So this is what I wanted to look at. There we go. Perfect. So, yep, 6500. I mean, the other one's fine too, but oh, am I looking at myself? No. Yeah, I'm not looking at myself. Okay. Yep. So we can see 6500, we don't see any of those sub-autonomous systems in there because we have aggregated them into a single Confederate autonomous system, 6500. That's what we see in all of our routing tables and in our path information. We can't even tell. It's completely invisible to the outside world, whether you're using a Confederation or route reflection. So let's just take a look at this side before I end the video, just for completeness sake. Okay, so yep, 65. There's the route tag. I'm just surprised that AS2 doesn't show up on this one, and then AS1 didn't show up on the other one. Is there like a detail or something I can use? No. Okay, but I think this is enough. We can see it's working perfect. Everything I said was true. It's working that way in the real world. We've just got this diagram implemented, so we overcame that full mesh requirement by making sub-autonomous systems and then aggregating them together into a Confederate autonomous system 6500, so that when we ping across our separate ISPs, all they can see is that there is one autonomous system that represents our ISP, even though we do have these several sub-autonomous systems. Okay, so that's the video. I finished it, so this topic is done. Oh my God. I don't know if I can do this every day, but this is definitely the goal, is to do one topic a day. That I do not think I will be studying hard enough if I cannot get through one a day. I think I will show up to the exam unprepared if I'm not able to meet that metric. So it's crazy, it's hardcore, but it's I mean, it's an expert level exam, and at this point it's now only 2 months of study. So what do I even have to complain about? Everything's on lockdown anyway. Let's get this exam. So yep, this will be the second video on the topic. So I will declare this done and get it uploaded soon, as soon as I can. All right, so see you in the next video for BGP adjacency formation. This one should be really easy. I'll give it 2 videos, but we know all about it. I'll go over the race condition thing using passive, just kind of go through all the options I have, and we'll spend 2 hours on this topic that I already feel like I have mastered. So thanks for watching, and I'll see you in the next one.